everybody. Today we are going to be solving inequalities. The book can be a nice reference. You can go to page 206, and of course our I can statement today is I can solve inequalities. Just a couple of reminders, and the difference between an equation and an equality is that an equation usually only has one solution, no solution, or infinite many solutions. It's not typical with an equation for us to graph it, because if I wanted to say x is equal to 3, it really serves no purpose of graphing. I can just say x is equal to 3. However, with inequalities, we graph it so that we can see the set of numbers that satisfies the equation. So with an inequality, there are many, many, many solutions. When you're graphing, just a couple of reminders that a closed circle is going to be less than or equal to, or greater than or equal to. In other words, that number is part of the solution. So when you see the equal sign underneath, then that tells us that it is part of the solution. And if you were graphing, you would want to make that a closed circle. If it's an open circle, then that stands for less than or greater than, and that means that the number is not part of the solution. In other words, every number leading up to or right before, but that means that number is not part of the solution. So there's just a couple of reminders as we start to graph. All right. Our first example, it says solve each inequality, graph each solution on a number line. If there's no solution, write no solution. We're going to approach an inequality exactly the same way that we would if the inequality sign was an equal sign. So in other words, we read this as x minus 1 is greater than 10. If I was going to solve this equation, I would just get rid of negative 1 on both sides. So we're going to show that step of adding 1 on both sides of the inequality. Bring down your greater than sign, so we end up with x is greater than 11. So to graph this, all I have to do is put 11 here. I like to put one number on either side of the number that would be the part of the solution. This says x is greater than 11. So what that tells us, a couple of things, is that 11 is not actually part of the solution, but that every number greater than 11 is part of the solution. So on the line, I'm going to draw a line and an arrow to indicate that every number, not including 11, but greater than 11 would be part of the solution. So for example, we can just randomly choose a number. Let's say out here, let's just choose 13. And if I went back in and I substituted in 13 for my equation, what this tells us is 13 minus 1 is greater than 10. 12 is greater than 10. And of course, that is a true statement. Number 2, I see a fraction, and we know that when we see a fraction in an equation, the first thing that we need to do is eliminate it or clear the equation of a fraction. Well, the same thing holds true for an inequality. So our LCD, I always want you to list that, is of course 2. And so that means that I'm going to multiply by 2, big parentheses, on both sides of the inequality. And then we would distribute. We're going to get, once we put the parentheses in, we were going to try to get rid of them. 2 times y is 2y, and then of course that's going to be a negative 1. 2 times a negative half would be 2y minus 1 is less than or equal to, we just bring that down, and then that's going to be a negative 10. Keep in mind that we multiplied by a positive 2. Just keep in mind that, just kind of put that in the back of your mind for me for a minute. And then we just solve, just like we would if it was an equal sign. I end up with 2y is less than or equal to negative 9. And then if we divide through, looks like I end up, keep my inequality sign. Looks like I have negative 4 and a half. And you might be wondering, well, Ms. McDaniel, why did you change it to a mixed number? Keep in mind that we're going to be graphing this. So I would rather graph negative 4 and a half than negative 2 halves. So to graph it, then I would say I like to leave numbers on my number line that are integers. So I've got -4, I've got -3, I've got -5 over here, just to kind of set it up for us. -4.5, of course, would be halfway between -5 and -4. And at the same time, I have to remember it is a closed circle because it is equal to. So y is less than or equal to -4 halves. Another rule, when the variable is on the left, then your inequality sign is going to point in the same direction as the line that you drew in. I'll say that again. When your variable is on the left, so we have y is on the left, and then notice our inequality sign is pointing to the left, then that's the direction that the line that I draw in is going to go as well. Remember, y means the solution. So if you're not really sure which direction to draw in the line, I would suggest thinking, all right, well, we're talking y would be the solution. In other words, the solution to this problem has to be less than -4.5. All righty, so now we have -6a is greater than 2 times the quantity 4 minus a. So I see parentheses. I know anytime I see parentheses, I'm going to have to get rid of the parentheses. So to do that, we're going to distribute 2 to both terms. So I end up with a minus 2a. 8 minus 2a. Now remember a couple of minutes ago I said, just keep in mind that I multiplied by a positive 2. The rule is that if I multiply by a positive, then you don't do anything with the equal or the inequality sign. However, if I divide through by a negative, then I have to change it out. So just want to keep that in mind as we're finishing up this problem. Now, I want to get -6a and -2a together. They are on opposite sides of the inequality sign, so we know that means to use opposite operation. So in other words, I'm going to add 2a on the right, and I'm going to add 2a on the left. That gives me a -4a on the left is greater than 8. Now, this is the trick, and you might want to stop and write yourself a note at this point that says when you divide by a negative or multiply by a negative, then you have to flip the sign. So I'm dividing through by a -4, that's the coefficient, that's the boss. We divide by -4, so now a, which was greater than, now becomes less than -2. Notice I didn't add an equal sign to it, all I did was flip the original sign. So if it's greater, you flip it to less. If it's less than or equal to, you switch it to greater than or equal to. And now it's time to graph. So we have a is less than -2, -2. And then you have to consider open circle or closed circle. Well, it's going to be open because it's less than. A is the solution, so we're talking about the numbers that are less than -2. So I'm going to go ahead and add a -3 here and a -1 just so that we can kind of sandwich our answer in between. Now, if we did not flip the sign, then this would be incorrect. So let's choose a number that is greater than -2 somewhere out here as a solution. I'm just going to use 0 because that's always a nice number to substitute in. So if I was checking, -6 times 0 is greater than 2 times 4 minus 0. And what happens? 0 is greater than 2 times 4. 0 is greater than 8. We can see that that statement is false. So I just wanted to show you on this first example where we had to flip the inequality sign, the reason, but now you can just memorize the rule that when you multiply by a negative or divide by the negative, you flip the sign. If we wouldn't have, you can see that we would have missed it because that is not a true statement. So we had to choose a number that was actually less than -2. And then our last example, I see a decimal. The first thing I should do when I see a decimal is to clear the equation of decimal. And all I'm going to have to do is multiply by 10 on both sides in order to get rid of the decimal. So we end up with what? -30c is less than 37 minus 30c. I like to keep my variable on the left because we know that's the direction we're headed. So I know I can't combine the like terms. I can if they're on the same side of the inequality sign, but as you can see, these terms are on opposite sides. So when I add 30c, something interesting is going to happen. Really, I end up with 0 on the left is less than 37. Now, this is where folks kind of get into trouble, so just take a deep breath before you call this no solution. And let's think about this. Is 0 less than 37? Is that a true statement? And the answer to that is yes, 0 is always less than 37. So if this is a true statement, then our final answer will be identity. And you might be thinking, well, how do I graph that? Well, we can just basically make a number line and then just make sure you're shading all the way over. And I say shading, but really we're drawing in a line. I'm just emphasizing, and it is going to go in either direction. Make sure you're including your arrows as you are drawing in your line. So just kind of a bonus question. What if I get to the end and I had something like 0 is greater than 37? Well, that of course is false. So we would say, yep, you guessed it, no solution. So when you get down to the bottom and you have your inequality statement, just ask yourself if it's true. Yes, this is true. That means it's identity. If the statement is false, then you have no solution. Can I graph no solution? Of course not. So then you would just be done with that. All righty. So that is going to do it for us for solving inequalities.